need help with? What are you not understanding? And then we will go from there. All right, so let's go ahead and put up a poll. If y'all want to go ahead and vote on what it is you would like from me. I've got 6 people that have answered so far. All right, so it looks like almost everybody wants to work on transformations. So let's go ahead and start with transformations of functions. Here we go. All right, so if you have not already written down the linear functions or the transformations of linear function rules, these are it. So if you want to take a picture, that's great. I also can put it in the announcements of the course if that helps anybody. Ty, I think that progress learning is not working at the moment, which is really unfortunate. So just be patient. It should be back up hopefully by the end of today. So, all right. So, we have a couple different transformations. If the function, original parent function is f of x. So if f of x has k added to it at the end, it's going to go up. Okay? If we subtract k outside of the parentheses, it's going to go down. Okay, so if it's adding or subtracting k and it's outside the parentheses, that means up or down. If it is adding or subtracting a number, we'll call it h, inside the parentheses, we're moving left and right. So it's going to move to the left when h is positive. So if we're adding h, it moves left. If we're subtracting h, it moves right. If we put a number in front of the parent function, we'll call that number c. If c is bigger than 1, or we're just looking at the number. So even if it's -4, if the absolute value of c, so just the base number, is bigger than 1, it's a vertical stretch. If the number for c is between 0 and 1, we call that a vertical compression. All right, and then we have horizontal and horizontal stretch and horizontal compression. So this happens when we put a number in front of x that's inside the parentheses. So again, when it's bigger than 1, it's a compression. 0 to 1, it's a stretch. All right, we have just a few more. If we put a negative number outside of the function, so before the f, we call this a reflection over the x-axis. If the negative is inside, if it's on the input, we call it a reflection over the y-axis. Okay, so those are just a few of the function rules. You won't be given these on your test. So you can, okay, back up. You can use these rules on your test, but on the STAR test, you will not have access to these rules. Okay, so just so you know, you are more than welcome to use these rules for purposes of the class. I'm getting there, AJ. You can use these rules, but on the actual STAR test, you won't have these rules. You can graph it though and see, okay, how much did it shift? So what does it look like on the test? Well, this is what it will look like. Compare the graph f of x equals x and g of x is f of x minus 6. What changed and what stayed the same? Okay, so we know that our original parent function, f of x, has a slope of 1. Okay. We also know that g of x, we don't have a number in front of this f of x, so this slope is still 1. Okay. So they still both have a slope of 1. But what has changed is this subtracting 6, and we subtracted 6 on the end of it. So it wasn't inside the parentheses with the input, it was this one, this top one. Okay. K was negative, so it's moving down that many units. So what changed is that g of x was shifted down 6 units. Okay. Questions about this one? We're gonna do some more practice ones together, some examples. Okay. If we were to go ahead and, so what I mean by you don't have to memorize the rules necessarily, but you can graph it. In your STAR Desmos version, you can put in for line 1, f of x equals x. This is your parent function, and it's graphed on this green line. That's the parent function. Then you can actually just type in g of x equals f of x minus 6. You would just type that into the second line, and it graphs it for you in blue. So you can easily see that the y-intercept has changed. And what stayed the same is the slope, because these are parallel lines. So the slope stayed the same. You can do it on a calculator. The only thing with the calculator is when you go to y equals, you will just put x. And then for your second y equals, you'll do x minus 6. So you can, it's just not quite as easy. Good question. Okay, let's try another one. So what I want you to do is think about your rules. Compare the graph f of x equals x, that's our parent function, to g of x, which is f of x minus 1. This time, the subtraction is occurring inside the parentheses. So it's happening to the input. Okay, so take a look back at your transformation rules. I'm going to click back real quick since I think you've probably had time to look. When it's happening inside the parentheses, we're looking at a horizontal shift. Okay. Our problem here says -1. So let's look and see what happens when h is negative. So when h is negative, that means we're moving to the right. So then I would come back over here and say, okay, g of x moved or shifted horizontally. Let's write it that way. It's a little more consistent. Okay, g of x shifted horizontally to the right one. Yeah, I can. To the rules. Sure thing. There you go. Okay, you're welcome. So we still have the same slope. So remember that slope is the number in front of x. So we still have the same slope, and we can see that when we graph it. Okay, so if you wanted to graph this, you could graph it. So what changed? Our x-intercept changed and our y-intercept changed. Okay, it was shifted to the right. We took this green line and we slid it over to the right. What has stayed the same is the slope. These are still parallel lines because they have the same slope. Questions on this one? All right, so let's see how it would look as a multiple choice question. We're going to do these next two as a poll. Which of the following describes G as a vertical translation? So we're talking up or down, which means outside parentheses, of down 3 units. So go ahead and take a vote, A, B, C, or D. Which of those represents a vertical solution? A vertical translation. Which of those would be a vertical translation, meaning we moved it down 3 units? So go back to your rules. Okay, I'm going to click back real quick. I think I can while this stays up. We want a vertical translation. Okay, so we're going down 3. Okay, so look at your top one. This happens, it moves down when we subtract k on the outside or subtract a number on the outside of our parentheses. Okay, so if you need to change your answer, go ahead. Can we get more than 6 people to answer? Okay, we're wanting to move it down 3, so we're going to subtract 3 on the outside of the parentheses. Are y'all with me today? Riley, Gabby, Micah, Sophia, Valerie, Sanaya, Alejandra, Noah, Aubrey, Michael, Karis, Adler, Sean, Rylan. Are y'all with me? Thank you, Adler. Thank you, Ty. Thank you, Sanaya. Okay, there we go, 13 people. So we're just waiting on 12 more. All right. So the correct answer, which 60% of you got correct, is C. So we want to go down, which means we're subtracting 3 on the outside of the parentheses. Good job. Okay, let's do this one. What if we want to go horizontal translation to the right 6 units? Okay, we're going to the right 6 units. So this is going to happen inside the parentheses. This is happening to the input, but be careful because horizontal translations are kind of backwards. So it's going to go to the right when we're subtracting. Okay, so if you need to change your answer, go ahead. Okay, we've got 9 people that have answered so far. So remember, horizontal is different. Okay, it's opposite of what you might think. If we're going to the right, that means we have to subtract. Okay, if you need to change your answer, go ahead. We're still missing some people. Riley, Gabby, Micah, Lena, Valerie, Alejandra, Noah, Rami, Michael, Sean. Okay, most of you are, about half of us have got it so far. All right, so let's go ahead. I will show you. We got 50% of us got it right. So because we're going to the right 6 units, but it's horizontal, we have to subtract 6. So the correct answer is A. Okay, let's take a look at these two. Tell me in the room chat, what has changed between these two graphs? So we've got f of x equals x. This is our parent function. And then we've got g of x, which is 3 times x. So what has changed? Okay, good, AJ, good. That's exactly right. The slope. So let's look at this if we were to graph it. The original parent function is graphed in green. And what has changed is the blue line. So the slope changed. The slope is steeper, okay? Or you can say it was a vertical stretch by 3. Correct. That's exactly right. The y-intercept has not changed. Very good. Exactly. All right, let's try this one. What will change in this one? Yes, Nola. So if we look back at our functions, our transformation rules, the function here, we're looking at this fourth row. Okay, so what's happened is we have a number inside the input, inside the parentheses, so with x. Okay, so that number was 1/4, right? 1/4 is between 0 and 1. So that means it was a horizontal stretch. Okay, so we're going to go back. And this actually does, let's see, horizontal stretch. This actually does change the slope because it's the number in front of x. See how it's horizontally stretched. So the line is flatter. Okay, so the slope has changed, but the y-intercept does not. Let's try another multiple choice. Which transformation is a horizontal compression? So we want a steeper line. So really quick, before I put the poll up, let's look at our rules. Horizontal compression, that's right here. Horizontal compression is when b is greater than 1 and b is inside the parentheses. Okay, so let's take a look. And what do you think? Good. There's 4 of you that have answered so far. Good. Now 5. Okay. We've got 12 of you that have answered. Remember, horizontal compression means that whatever is changing, it's happening inside the parentheses. Okay. Since we want a horizontal compression, compression means that our number has to be bigger than 1. So 46% of us got it right. That would be C. We've got a number 5 inside parentheses. That tells us it's horizontal compression. The 5 being bigger than 1 tells us it's a compression. All right, take a look at this one. Which of these statements is true? The function g is a reflection of f over the x-axis. G is a reflection of f over the y-axis. Not a reflection, or it's translated down. What do you think? So remember, if it's a reflection over the x-axis, that means we're going to fold it in half like a hamburger. So like the top is going to go down to the bottom, and same. If it's a reflection over the y-axis, that means we're folding it like a hot dog. And the middle point would have to be the y-axis. So take a minute to think about those. What do we think? Let's go ahead and talk through this. I'm going to start at the bottom here. So letter D says function G, so purple, is a translation of F 2 units down. So that would mean that we would just move it 2 units down, but it would still have the same slope. We know that that is not true because G now has a negative slope. So it cannot be D. C says function is not a reflection over either axis. Okay, well, it's a potential. Let's leave that there, but let's rule out X and the Y axis first. So to be a reflection over the Y axis is right here. Okay, I'm going to put like a dotted line. That means whatever we have on this left side, we would fold it over here. Okay, but you can see that this reflection actually happens when it happens vertically. It actually happens at -2. So this is not a reflection over the y-axis. But we do, for part A, the reflection over the x-axis. So if I fold this perfectly in half at the x-axis here, that means this purple line would come down to the bottom, the green would go to the top. Well, since these both have the same slope, that would be true. So this is a reflection over the x-axis because where they intersect happened at the x-axis. Okay, that one's kind of tricky. Okay, what about if you're given something that looks like this? So you get to choose the type of transformation. Okay, I've got them listed for you. A student 1/3. How are these two graphs related? Okay, so we've got a number outside of the function, and this number is between 0 and 1. Let's look at our rules. A number outside, that's this third one. Number outside the function, the number is between 0 and 1. So this would be a vertical compression. Let me go back to it. There we go. Okay. Transformation would be the letter E, vertical compression. What if we have more than one transformation? So let's take a look at this one. A student graphed f of x and g of x on the same grid. G of x was 2/3 times f of x. Again, we have a number between 0 and 1 on the outside. Okay. Also on the outside, we added 4. So please describe how these are related. Well, let's talk about the first thing we see, which is the 2/3. So again, a number outside the parentheses between 0 and 1. So that's going to be a vertical compression. Then the adding 4 at the end means it's a vertical shift up. So we would have E and A. All right, I've got 2 more for you. So I want you to try these on your own. What do you think about this one? There are 2 transformations. You can put it in the room chat, whatever the 2 letters are. Good, Nola. That's perfect. Anybody else got it? Can anybody give me a guess? What two letters do you think? What are the transformations? So we need to figure out, what does this negative mean? And what does the +2 at the end mean? Even if you just know one of them, that would be fine. Are we confused? Are we not here? What's going on? Can y'all tell me what you're confused? Do you not have the rules? Do you need me to go back to the rules? What are we stuck on? Okay, I can wait. I mean, it's okay. I'll just wait until somebody tells me what's going on. I can't just do every problem for y'all. That's not helpful, because clearly me doing them all is not helping you to learn it and do it on your own. So I will wait. Okay, well, this is not really a word problem. Did you understand how we did the last two? We're not concerned with any of the words in the problem. All you're doing is you are looking at what is different. So what is different from this graph to this graph? So the things that are different, I circled them. The negative sign is different, and then we added 2 at the end. So you're going to go to your rules, find what they look like over here. Actually, if you want, I can paste the rules again. Let me grab the rules and I can paste them in here so that you can have them. Yeah, they can have more than one transformation. That's what we did last Wednesday in our class kick. We were in whole group and we had that class kick assignment that we did together. They all had more than one. All right, let's see if it will let me paste this. All right, so here's some rules. I don't know if you can see those very well. I can make it bigger for just a second, but all right, so if we compare, we see a negative sign out in front. Here's a negative sign out in front. What does that mean? Boom, that's it. That's all you have to say. Reflected across the x-axis. I see a +2 added at the end. Here's a +2 added at the end. So shifted up 2 units. Okay, let's try another one. Guys, I understand if you don't understand like what's going on, but we have spent 36 minutes going over this and you're just now telling me that you don't get it. So I need to know, what about it are you not understanding? Do you not have the rules listed out? Because if you don't have the rules, this is really hard to do. So tell me what it is that's messing you up. Is it multiplying things? Is it when things happen inside the parentheses? Help me to help you, because I've been trying to and have just been teaching for 36 minutes without anybody saying that they had any questions at all. So let's take a look at this one. Okay, AJ, what about it looks different? because what this picture that I'm using right here, this is what we used last week in class. And this is what I put on the homework assignment for you. So let's highlight what's different. Well, it's not really new because we talked about it last week and you did homework on it last week. But everything we're learning in algebra is new, yes. But that's just how it goes. That's kind of school, right? We're learning all new stuff. So this is like the third week that we're working on this. So what we need to do is go through. This is our original equation. So let's highlight what's different. The original equation just has x, okay? It does not have this 2. It does not have a plus 5 in parentheses, okay? So now what we're going to do, we say, okay, there is a 2 outside of the f of x. Where do I see that on this middle row? If there's a number outside of f of x, this does not have one, does not have one, does not have one, does not have one. Has a negative. Nope, does not have one. Oh, right here. If a number bigger than a, 2 is bigger than a, sorry, bigger than 1. If your number a is bigger than 1, okay, 2 is bigger than 1, and it's outside f of x, then that means we are stretching vertically. That's it. That's all you have to know. So for the first transformation, it's a vertical, whoops, there's my pen. Vertical stretch. That's it. So you don't have to worry about what, yes, the slope is different. And the y-intercept will be different, but it's asking you what is the actual transformation. So what is happening? It wants a description. So inside parentheses, I have adding 5. So let's find on this middle row where I have something being added in the parentheses. Okay, so that would be right here on this top row. I have f of x plus a number h. So x plus 5. So I go to the right. What does this mean? Shift left 5 units. So this would be a horizontal shift. Five to the left. If you don't have these rules written down, you are really going to struggle. So if you didn't take a picture of them or a screenshot or write them down, you need to do that. Otherwise, you are really, really, really going to struggle. Okay, I'm going to pause so that if you need to write them down, you can. All right, so guys, before you go today, I want to just kind of give you some hard truth. Some of you are telling me that you're not understanding this, and I'm going in to the course and going to your profile, your progress, and I can see exactly how many hours, minutes, and seconds you've spent in the course total, and how much of the content you have accessed. So like if it's a slide that has a video that you're supposed to watch and the video is 10 minutes and you spent 20 seconds, that tells me you did not watch the video. Okay? You will not get everything you need from algebra. You will not get it just from coming to class once a week. Okay? High school is much different than the middle school. Okay? You have to go log into the course, and there is a teaching video there for you every day. But we don't have live group every day. Okay? It's impossible to learn algebra, 5 days worth of algebra in one 45-minute session. Okay? So please, it is harder. It's harder. Yeah, it is. So please make sure that you are logging in every single day and watching the instructional videos that are posted for you. Okay, some of them are super short, like the transformation videos that are in 4.02. It's super short. Okay, there's like 4 different videos, but they're all like 3 or 4 minutes. Okay, and then there's like a big review one that's still only like 10 or 11 minutes. Okay, so you please make sure you are watching the videos, because if you're not watching the videos every single day in the class, there's no other way for you to get the information. Okay, because we don't have time to go over them in class every single day. Okay, because we don't have class every day. We only have live once a week. Okay, so please make sure you're doing that. We've still got all of November and 2 weeks pretty much in December for you to get your work in. So please make sure that you are doing what you need to do from here on out. And if you haven't watched videos, then it would be a really great time to go back and watch some of those videos so that you're not totally lost. Okay. All right. Y'all have a good week, and I will see you in small group tomorrow if you would like some help with anything.